Hello, I am Dr. Bob. I am going to show you how to set up the Yuasa External Control Package, or ECP. I will be using the motor drive unit DLDM111LH with the U-shaped folding test jig FS-C. The instructions would be similar with other motor units and jigs. Also, I will be using the Hioki resistance meter RM3545. It is equipped with the Hioki Multiplexer unit Z3003, which is installed inside the meter. The multiplexer allows up to 20 simultaneous resistance measurements. I am also using a terminal box that connects the multiplexer to the sample. There are 10 channels on the terminal box. And I will be using my own computer, a 15-inch HP Pavilion laptop with Windows 10 Pro. Windows 7 or higher is acceptable. I will be using sample software provided by Yuasa. You may wish to develop your own software to perform more sophisticated tasks. Some examples are recording multiple measurements per reciprocation cycle, analysis of the test data during the endurance test, and using the test data to change the test program. The sample software allows up to 8 simultaneous resistance measurements. I have already attached the jig to the motor unit. I have already set up the reciprocation distance and the folding radius based on the test sample I will be using. I already have the test sample mounted on the jig. If you need help on these setups, please see the Yuasa FS-C installation video and the Yuasa FS-C setup video. This is my sample, and it is set up for a reciprocation distance of plus and minus 35 millimeters with a folding radius of 5 millimeters. We will be making 4 simultaneous resistance measurements on this sample. There are no tools required to set up the ECP.
Here are the steps. Download the ETM sample software, download the Hioki software, set the motor unit IP address, set the laptop IP address, connect the motor unit to the laptop, install the Hioki driver, connect the Hioki to the laptop, confirm the Hioki COM port, set up the Hioki options, connect the Hioki to the test sample, edit the program data file to set test cycles and speeds, run the sample software application, type your machine name into the app, connect to the endurance testing machine, and finally connect to the Hioki machine. Then you'll be able to run tests. Let's look at these steps one at a time in detail. Step 1. Download the endurance testing machine sample software. I already downloaded the sample software. If you do not have the Yuasa sample software, check with your Yuasa contact for a link. The file I downloaded was a zipped file. I extracted the files into a directory that I now have open on my laptop. There is an application etm.exe, a configuration file etm.exe config, and a program data file programdata.csv. I made a copy of the original program data file and called it programdataoriginal.csv to keep a copy of the original file. Step 2. Download the Hioki driver software. I already downloaded the Hioki driver. If you do not have the driver, you can download one at the Hioki website www.hioki.com. The driver is in a zip file rm354x app rev4.zip. I extracted the files into another directory on my laptop. The driver is Hioki USB CDC driver.msi. Step 3 is to set the motor unit IP address and subnet mask.
You use the touch panel on the motor unit to set the IP address. Touch the Settings button on the bottom right corner and the current IP address will appear. The setting should be 192.168.0.1. If it is not already correct, touch the first group of numbers, then touch 1 and 9 and 2, and then enter. Then touch the second group and touch 1 and 6 and 8 and enter. Then touch the third group, enter 0 and then press enter. Then touch the fourth group and touch 1 plus enter. So now we have the IP address 192.168.0.1. The subnet mask is set by the same process. Enter the numbers 255 and 255 and 255 and 0 as you did for the IP address. Both of these numbers are likely to already be correct. I changed them intentionally so you can see what to do if a change is necessary. Touch and hold the Renew button to lock in these values. This is rebooting the touch panel.
Step 4. Set the laptop IP address and subnet mask. The procedure to set the laptop IP address and subnet mask can be different depending on your computer and operating system. I will go through the steps on my laptop. My operating system is Windows 10 Pro. Your steps will be similar, but not necessarily identical to what I am showing you here. Right-click on the Windows button in the bottom left corner of the screen, then left-click on Settings. This opens the Settings window. Click on Network and Internet to open the Network Status window. Under Change Your Network Settings, click on Change Adapter Options. This window shows the various network connections, which in my case are Bluetooth and network cable and Wi-Fi. Double-click on the network cable, then click on Properties, then click on Internet Protocol version 4, then click on the Properties tab. Before you change your IP address, you might want to make a note of the current IP address because you may want to go back to that setting when you are finished with the endurance testing machine. Often the setting is obtain an IP address automatically, which is my case. This is called DHCP, where the network server assigns IP addresses to computers on the network. Most laptops will be set up this way so they can lock onto new networks as they are moved about. In the upper half of the window, click on Use the following IP address and enter 192 and 168 and 0 and 5 into the IP address window. Then enter 255 and 255 and 255 and 0 in the subnet mask window if they are not already there. Then click on OK. Then you can close all the windows you opened to set the IP address. If you have a different version of Windows, your first step to change the IP address might be to open the Control Panel, then Network and Sharing Center, and change Adapter Settings. Then click on the network cable as before, and Properties, and IP4, and the same thing as before. Step 5 is to connect the motor unit to the laptop with an RJ45 cable. I'm not filming this. You can just go ahead and plug in the cable at both ends. Step 6 is to install the Hioki driver in the laptop. I described the Hioki driver software in the second step. To install the driver, simply double-click on the driver Hioki USB CDC driver.msi. Then click on Next. Then click on Next to install in the directory. Click on Next to install. Now it's installed, so we close. Connect the Hioki to the laptop with a USB cable. You can go ahead and plug in the USB cable at both ends. I'm not filming this part. Confirm the Hioki COM port. Let's make sure the driver is installed. Right-click on the Windows button, then left-click on Device Manager. Click on Ports. Find the Hioki USB driver in this list. Its presence confirms the Hioki meter is installed, and it will show the COM number. In my case, it is COM3.
Step 9. Set up the Hioki RM3545 options. We need to check the multiplexer settings on the front panel of the Hioki meter. We see that they are set for MUX, Auto, and Scan. There are 4 channels. That is the correct setup. However, if the hierarchy is set to the factory default, there are two settings that you may need to change to use the ECP software. They do not show on this screen. They may already be correct, but we will check them. First is the interface. Factory default is RS-232. What is needed is USB. Press Menu to reach page 2 of 3. Press F4 for setting. Press the left or right arrow on the panel to reach IF. Then press the down arrow to reach interface. At the bottom of the screen, press the F3 button for USB, then exit with the menu button. Second is whether measurements are made using the front panel terminals or the multiplexer. Factory default is front panel. Press Menu to reach page 3 of 3. Press F2 for MUX or multiplexer. Press the menu button to reach page 1 of 3. At the top of the screen, you will see MUX, Auto, and Scan, and 4 channels. These are the correct settings for using the multiplexer. Let me show you how to set the RM3545 back to factory default. You might need this if you have been making changes and you are not sure where you are. Press Menu to reach page 2 of 3. Press F4 for setting. Press the left or right arrow to reach SYS. Press the down arrow several times to reach Reset. There are 3 options for reset: just the multiplexer, or normal reset, or system reset. Press F4 to select System, then press F2 to confirm. Now you have set the meter to the factory default. If you press a wrong button along the way, press the Escape button ESC on the front panel. Now that I have changed to factory default, I need to reset the items I mentioned when I started step 9. First is USB interface. Press Menu to reach page 2 of 3. Press F4 Setting. Press the right arrow on the panel to reach IF. Then press the down arrow to reach Interface. At the bottom of the screen, press the F3 button for USB, then exit with the menu button. Second is Multiplexer Measurements. Press Menu to reach page 3 of 3. Press F2 for MUX. Press Menu to get back to page 1. We may have changed the channel selected for measurement by doing the reset. In fact, we can see this has happened. We only see channel 1. Press Menu to go page 2 of 3. Press F4 Setting. Press the left arrow to reach MUX 1. Then turn on channels 1 to 4 if they are not already on by pressing the down arrow to channel 1, and then the right arrow to the setting, and then F3 for on. Do this for each of the channels 2 through 4. Press the menu button to reach page 1 of 3. At the top of the screen, you see MUX, Auto, Scan, and 4 channels, which is correct.
Step 10 is to connect the Hioki Z3003 to the test sample. The multiplexer is installed inside the meter. The terminal box plugs into the multiplex connector on the back of the meter. A cable is attached to the terminal box and ends with a connector. The plug on the sample goes into this connector. You should go ahead and make that connection. Step 11 is to edit the program data file to set the test cycles and speeds. As described in the first step, there are 3 files in the sample software. And as I said, in order to keep a copy of the original program data, I copied it and named it programdataoriginal.csv. Let's look at that original file using Excel. The file is a sequence to the ETM application will follow in automatic testing. There's 2 columns. The first column is the number of machine cycles that you will run at reciprocation speeds shown in the second column. When the first step or row in the file has completed, resistance measurements will be taken and the program will move to the second step or row. Note that the count column is cumulative counts, not the count for that specific step in the program. The program data file that comes with the sample software has many steps, 2,000 in total. You edit this file to set up your own sequence. I have made my own very short sequence for this video, only 6 steps. Let me open that file with Excel. I have 5 cycles at 30 reciprocations, 5 at 45, 5 at 60, 5 at 75, 5 at 90, and then 5 more at 30 reciprocations per minute. Let me close this file. It has to be closed or the application will not run properly. Step 12 is to run the sample software application etm.exe. So you can start the program now. I'm double-clicking on etm.exe. The left panel is the program data, the middle panel is the motor unit data, and the right panel is the Hioki meter data. Step 13 is to type the machine name into the box ETM name. So you enter the motor name, your motor name unit, in the ETM name box at the top. In my case, it is DLDM111LH. Other machines using the Yuasa sample software could be DMLHB, or DMLHP, or DMLHPR, or TCDM111LH. Step 14, we connect to the endurance testing machine. To connect the laptop to the machine, click on the Connect/Disconnect button next to the ETM name. The button becomes green. Motor unit data appears. The modes shown at the bottom, and it comes up in manual, not automatic.
Step 15, connect to the Hioki meter. In Step 8, we check the COM port number. If it was not the same as the COM port showing in the digital multimeter portion of the ECP application, you must edit the COM port in the ECP application before connecting the Hioki meter. To connect the laptop to the Hioki RM3545, click on the Connect/Disconnect button at the top right of the ETM application. The button becomes green. The manual mode disappears and only automatic shows. If you are having difficulty connecting to the Hioki, check to make sure you have the Hioki set for USB interface and check to make sure you have the proper COM port. If you are making fewer resistance measurements than shown in the digital multimeter portion of the ECP app, you can simply uncheck them before running your test. In this test, I am making 4 measurements, so the checks are already correct. We have completed all the setup steps. Now we are ready to operate the motor unit and take resistance measurements under the control of the laptop.
To operate in the manual mode, the Hioki meter cannot be connected. Click on the Disconnect button if it is connected. The current count shows in the ETM app's Count window. It also shows on the motor unit's touch panel. The motor unit will operate at the reciprocation speed shown in the ETM app speed window. That value also shows on the motor unit's touch panel, and it shows in the ETM app's Read SP window. You may need to click on the ETM app's Reload button to make sure the current motor unit's value is showing in this window. The target number of counts shows on the motor unit's touch panel. That value will also show in the ETM app's Read Count SP window. You may need to click on the ETM app's Reload button to make sure the current motor unit's value is showing in this window. To change the count or target or speed values using the motor unit's touch panel, tap Count on the touch panel. Touch and hold the Reset button to set the count to 0. You have to hold it a couple of seconds. Touch the current number for target, and then you can set that value. Let's set it to 29. To change the speed value, tap Speed, then tap the current number for speed, and then you can set that value. Let's set it to 27. Press the Home button to return to the main screen. You can change the target count number and the reciprocation speed with the ETM app. Now I will set a target of 10 cycles in the right Count SP window and a speed of 30 reciprocations per minute in the right Speed SP window. Then I click on Write. Those two numbers will now show in the Read windows, and the motor unit's touch panel will have updated when I clicked on Write. You cannot reset the count with the ATM app. You can only reset the count from the motor unit's touch panel. Let's run the motor unit in manual mode. I already set the count on the motor unit's touch panel to 0. This is an important step. If the count is not 0, the operation will begin at that count. If the count is equal to or greater than the number of counts set as target, the motor unit will not operate at all. To run in manual mode, click on the ETM app's Manual Select button. We have to disconnect the hierarchy meter if it is connected. Then click on the ETM app's Start button, and the motor unit will begin operation. The motor unit will stop if you click on the ETM app's Stop button. Click Start to continue. It will stop when the count reaches the target number. If the target number was set to 0, the motor unit will continue to operate until you click on Stop. In this case, we set a target of 10 counts, so the motor unit stops after 10 counts. The motor unit operated for 10 cycles at a speed of 30 reciprocations per minute. Now we will run the machine in the automatic mode. We must connect the hierarchy meter by clicking on the Connect button. The sequence we will follow shows in the left panel of the ETM app. This is showing the numbers from my programdata.csv file we looked at earlier. Reset the count on the motor unit's touch panel to 0. We will save the data in a file I will name savemydata.csv. The default is savedata.csv. If the file already exists, the software will ask if you want to append the data after you have clicked on Start. Make sure the hierarchy meter is connected. Click on the Connect button if it is not connected. You do not need to click on the ETM app's Automatic Select button. The manual choice does not exist if the hierarchy meter is connected. Then click on the ETM app's Start button. Before the motor unit begins operation, a measurement is made by the hierarchy meter. You can see the measured values on the laptop screen. Then the motor unit goes into operation on the first step of the program data file. We are running 5 cycles at 30 reciprocations per minute. About half a cycle before the end of the first step, the motor unit slows and the hierarchy meter takes another measurement. Then we run 5 cycles at 45 reciprocations per minute. Again, about half a cycle before the end of the step, the motor unit slows down and the hierarchy meter takes another measurement. Then we run 5 cycles at 60, and the motor unit slows down on the fourth of those steps, and the hierarchy meter takes still another measurement. Then we run 4.5 cycles at 75. Slow down, stop, take a measurement. Then we run 4.5 cycles at 90. Slows down at the end, takes the meter readings, and then it finally runs the last step 5 cycles at 30 reciprocations per minute. Once again, the motor unit slows down close to the end, and the hierarchy meter makes the final measurements. The automatic test cycle has completed. Let's look at the savemydata.csv file that recorded our steps and the resistance measurements. The first column shows the date and time of each step, but I need to expand it so that the full amount of data in that column shows. The second column shows the cumulative count of cycles. The third column shows the speed during each step. Columns after that show the resistance measured by the different connections at the beginning of at the beginning and at the end of each step. And here we have the listing of all the samples at each of the steps. You will find some differences in the automatic mode depending on your setup. The DMLHP and DLMHPR will not slow down the last cycle. Also, you can use the sample software without the hierarchy meter. The only difference would be that the motor drive does not slow down on the last cycle of each step. It moves immediately from one step to the next. There is one more setting on the hierarchy RM3545 you might need to change at some point. The factory default setting for resistance measurements is 4-wire, not 2-wire. Most multimeters you have used in the past were 2-wire instruments. You put a probe at each end of a resistor and read the value. A more precise reading can be made using the 4-wire technique. You use one pair of probes at each end of the resistor to put a current through the resistor, then a second pair of probes at each end of the resistor, but inside the other probes, to measure the voltage. This minimizes the effect of the leads. Here's how you change from factory default of 4-wire to 2-wire. But first, why might you want to do this? The multiplexer in the hierarchy can make up to 10 4-wire measurements or 21 2-wire measurements. If you want to do 2-wire measurements, press the menu button to reach page 2 of 3. Press F4 for setting. Then press the right arrow to reach SYS, SYS. Then press the down arrow to reach wire. If it says 2W, you're already there. If it says 4W, press the F3 button for 2W. Then press F2 to confirm and the menu button to exit. Note that the terminal box provided with the Yuasa ECP software is 4-wire. If you wanted 2-wire measurements, it would be necessary to make a different terminal box. If you change between 2-wire and 4-wire measurements, make sure you have set it properly before running tests. Most Yuasa users of the RM3545 will use the multiplexer and terminal box to make multiple resistance measurements. The terminal box can make up to 8 measurements. An option is a terminal box with a second Z3003 and modified ECP software that can make up to 20 measurements. As you can see, there are multiple settings you can change on the RM3545. I have covered the most likely changes you will want to make. Another area I will cover is single-channel measurements. It is possible to use the ECP and RM3545 to make single-channel measurements without a multiplexer. If you have the L2101 clip leads, you can place the L2101 on the front panel terminals. Press the red lead into the top red terminals with the arrow on the lead facing the arrow on the meter. Black into black. And the gray lead into the guard terminal. Set the measurement to be front by pressing Menu to reach page 3 of 3, then F1 for front. It will automatically select 4-wire. You can exit with the menu button. Now you can use the ECP software and make single-channel measurements. If you do have a multiplexer, you can use the same technique for single-channel measurements. The L2101 clip leads on the front panel. In either case, the RM3545 must be set for front measurements. Otherwise, you could get incorrect results. Or you can use a D-sub-50 pin receptacle and 2 wires to the appropriate pins for 2-wire measurements, or 4 wires to the appropriate pins for 4-wire measurements. Here's a single channel cable I made using 2 wires. This plugs into the multiplexer on the back of the hierarchy and runs exactly the same as MUX in our test, but only one channel is measured. This concludes the Yuasa ECP setup video.